So in the last video, we have talked about how we can form a differential equation. And luckily for us, in the last differential equation, there was only one variable, which is v. However, in real life situation, in real situation, that doesn't happens a lot. So usually there is the kind of differential equation in which there are two variables that involves. So an example would be sometimes a differential equation of dx over dy might be equal to x times y. So we need to solve this. So solving a differential equation is basically losing this. So losing this, you can do it by simply integrating. So how are we going to do it in this situation? So normally, if there was just one variable, all you have to do is integrate on this side. But now you have to do it on both sides. So how do we do it? So first just check. So usually it is dy over dx, but here I put dx over dy. So you can imagine in different situation where there is t, v, or others, you can still do the same way. So say we have dx over dy is equal to x times y. And so first you need to check on this side if it was dx at the top. So find a way to put all the variable that is related to the x on the other side. So here you can have 1 over x dx over dy is actually equal to y. And then what you can do next is simply integrate these two. So with respect to dy, so 1 over x dx dy is equal to y dy. So dy and dy could be gone, and here you have integration of 1 over x dx. And here you have ln x is equal to y squared divided by 2. So simply, this is how you solve a differential equation. Now let's look at a real example question. See how are we going to do it. Right, so let's just say we have this solved question. The acceleration of an object is inversely proportional to its velocity at any given time, and the direction of motion is taken to be positive. When the velocity is 1, the acceleration is 3 meters per second square. Find a differential equation. The first one, the first question, here's how we're going to do it. So the acceleration of objects, acceleration is change in v over change in t. It's inversely proportional to its velocity. So proportional to is equal to k over v. Inversely proportional to its velocity, that gives us this. The direction motion is taken to be positive, so that's a plus. Now, when the velocity is 1 meters a second, the acceleration is 3 meters a second. So when v is 1, so we have the acceleration is 3. So 3 is equal to k over v, so k over 1. So we have k is equal to 3. So dv over dt is 3 over v. Simple. Now, the second question. Find the particular solution to the differential equation for which the initial velocity is 2 meters per second. Now, question 2. First, we need to solve this differential equation. So we have v dv over dt is equal to 3. Remember, v is here, so we move v here. So integrate them both. Here we have v squared over 2 is equal to 3t plus c. 3t plus c. Now the initial velocity is 2. So that is when t is 0. So v velocity is 2. So we get c is equal to v squared. So v squared is 2, right? 2 squared 2, that gets us 2. So this is actually v squared is equal to 3t plus c over 2, 3t plus c, which get us v squared is equal to 6 plus 4c. Let's do c. Now here we get 4c. No, sorry, there's no c. there's 3t plus 4, 3t plus 2, and then here we have 6t plus 4. So v squared is equal to 6t plus 4, and thus we have v is equal to the root of 6t plus 4. Also, because v is positive, so this is positive, it cannot be a negative. So that is how you solve a differential equation. Now for the last question, let's do it this way. Now for question 3, so we have has v is equal to the root of 6t plus 4. So how long does the object take to reach a velocity of 8 meters per second? So simply v is 8, so we have 8 equal to the root of 6t plus 4. So 6t plus 4 is equal to 8 squared, which is 64. So thus we have 6t is equal to 6t, and t is equal to 10. Right, t is 10. So once you have the differential equation, there'll be questions like this and you can solve them. So that's how you solve a problem like this. Fairly simple.